I'm going to talk about two very different topics. I mean, they're both related to Spark, which, you know, committer on Spark, so it kind of makes sense. But I'm going to talk about how we can teach kids Spark, and then I'm also going to talk about like some kind of gnarly things that we can do with Spark to make it not catch on fire quite as often when dealing with certain types of data. And admittedly, like, the second part may make you think that the first part is a bad idea and like kids should not be exposed to custom encoders. But I think that we can just say, you know, maybe children won't have to deal with sparse matrices, or at least I hope. So yeah, I'm Holden. My pronouns are she or her. It's tattooed on my wrist. It's very convenient in the mornings when you wake up and you're like, who am I? Where am I? What's going on? Been at a bunch of different companies, co-wrote a few books. And of course, you know, my publisher would be very upset with me if I didn't point out that these books are excellent gifts and they come in lovely boxes. And you should definitely buy several copies with your corporate credit card. And if you don't have a corporate credit card, don't worry about it. But if you do, it is an excellent gift. Ideally, don't send it with a gift receipt because it is just a little tacky and people might actually return it then, and that's just not good. So excellent gifts for everyone that you're working with. You can follow me on Twitter. That's a lot of complaining about American healthcare. If you've ever, you know, been thinking about moving to America, you can definitely follow my Twitter to find out why you shouldn't, or why you should. The SlideShare, I don't keep as up to date as I used to, but I'm working on it. Another thing, and I'll actually be doing a live stream later on today. I do a lot of open source live streams, and the live stream that I'm going to do later on today, assuming that the vote passes, is I'm going to make the finalize the Spark 3.1.3 release. I think that's the right version. And I'll also be publishing the Spark Docker containers for the 3.2.1 release, or 3.2.2. I'm a little fuzzy. Anyways, but I'm going to do a live stream of sort of some of the release process this afternoon, most likely. And of course, there's my GitHub. There's a bunch of code there. Oh, right, yeah, and I don't speak for my employer, but if anyone is looking for a job, and admittedly, I think we're mostly focused in the US, though, or at least the North American time zones, we are hiring actively for Scala and other devs. So please definitely do reach out, and I can put you in touch with the right people. Okay, cool. So in addition to who I am professionally, I'm trans, queer, Canadian in America on a green card, finally. Happened during the pandemic, and a part of the broader leather community. And now this isn't directly related to these things, but I think it's important for those of us who are working on data tools and machine learning tools to try and have diverse teams at the table when we're building things. And I think one of the things that we need to do is talk about where we're from. And if we realize that we're all from the same background, that's maybe a really good time for us to like reach out to some other people and try and make sure that their voices are included or they're involved in the process of building stuff. So yeah, well, we're going to talk about sort of some weird things. I am also, maybe depending on how time goes, take a quick little detour into this like Spark flowchart that I've been working on for debugging Spark. This is like mostly just things that I'm really excited about and I really want to share with y'all. They're all Spark related because I'm a nerd, but distributed computing for kids, Spark encoders, and then also like how to debug your Spark jobs. But that one is very much if there's time. The last one, I'm not super sure we'll have the time for it. So why are we talking about all of these different things? I'm easily distracted. I multitask a lot. Like on a given day, I'll actually probably switch between these 3 different projects, maybe even 4 several times. And none of them are really a full-length talk on their own, and they're all related to Spark. So my hope is that y'all like Spark, and that's enough to keep y'all interested. And if not, it's totally cool. There's a whole bunch of different talks. You know, feel free to go and explore. You know, take a coffee break. Life is really chill. So why distributed computing for kids? So I think Spark did an excellent job of tricking a lot of adults into learning functional programming. And it did this by not telling them we were teaching them functional programming. And I think that we can do the same thing with kids. It's considered impolite to trick kids, but we'll call it teaching, yeah. And maybe we can use these same techniques that we use with adults, which is like, hey, look, you can do this really cool thing. And then after they've learned it, you're like, oh, by the way, this is called functional programming. And you can use this for a whole bunch of other things too. It's really cool. Okay, thanks for spending, a week reading this book. The other one is gnomes are really cute. So what does distributed computing for kids look like? So this is, obviously a very rough draft, but we can see we've got some gnomes, we've got some humans working on their laptop, and they are going to be writing some distributed computing software. So Alex and her friend Ziva love to play on the weekends. And this weekend, they really want to take photos for Instagram, and they want their photos to be popular with their friends. But to know what's popular, they don't want to just look at what's trending. They want to see what the top tags are that their friends are using. And the Instagram app doesn't show this to them. And figuring this out by hand, like going and looking at all of their friends, would take a lot of time because they're really popular and they have tons and tons of friends. But the good thing is they have all of their garden gnomes hanging out with them in the backyard. And, in exchange for some tea, the garden gnomes could probably help them figure out what's popular. And in case you're not seeing where this is going, the garden gnomes might be the computers in the future, yeah? But it's good. So, in exchange for some tea, the gnomes offer to help Alex and Ziva, and the gnomes will look up the tags for the most recent posts from all of their friends. Since they're mostly on Gnomestagram instead of Instagram, they have to install the Instagram app on their phones. And while it's installing, Alex and Ziva start by writing down a list of all of their friends' Instagram accounts. Now, they do this on a stack of index cards rather than one big piece of paper, because they need to be able to split it up and divide this list amongst the different gnomes, right? And if they just wrote it on one piece of paper, it would be really difficult to split it up, right? You'd have to cut it with scissors, and that would be kind of annoying, not much fun. Okay, and here we have one of the gnomes looking at some index cards, and there's some tea brewing, very good. This is an important part of distributed computing. You have to have your warm beverages, otherwise the computers don't work. We all know that. And so the gnomes have a little conversation together to decide who the leader is going to be, and they agree that the gnome with the blue hat is going to be their leader. So this is our wonderful leader. In this case, the leader is, probably equivalent to the Spark driver, more or less. And she takes a look at the stack of the cards, and she tries to figure out how many cards to give to each of the gnomes. And this is a really important part because think about if you're splitting up work with your friends, if you give one of your friends most of the work and another one of your friends just two things to do, it's not going to be very fair, and also it's going to take a lot longer for things to get finished because the other friend is just going to be hanging out waiting for the one friend who got too much of the work to be finished. And all of the gnomes are given a fair share of the work by the gnome with the blue hat, and this is actually pretty challenging, but it's good. And the gnome with the blue hat is responsible for keeping track of everyone's work, because that is work in and of itself, right? Figuring out hey, is everyone doing their job? Is everyone finishing what it is that I asked them to do is work. And that's really hard to do. And that's what managers do. Although, of course, managers also do other things. And I have opinions about managers that I shouldn't say while we're being recorded. Some of my best friends are managers. I took a brief stint in management. Let's be clear. Please continue to not fire me. But yes, sorry, detour. So each of the gnomes starts looking up, what the different posts are from the index cards that they've got, and they start writing down, okay, this is the tag that I saw, and every time they find a new tag, they make a new index card, and it's going to end up looking something like this, right? So like, there's a really good chance that I would tag my post with coffee and best dog, because I like coffee. Professor Timbit, come on, Professor, little buddy. Oh, he's not coming. It's very sad. Professor! Come on. No running away. No running away. You have to see our friends. You have to see our friends. Professor! Professor. I love you. Yeah, he is the best dog. Oh, your breath smells like, yeah, not good. Oh, God. I guess I deserve that. Thanks for coming, buddy. Okay, back we go. Okay. Sorry, very, very important part of the talk. I love you, little bud. Oh, good shake, buddy. Good shake. Okay. So yeah. So here we see the gnomes are hard at work, right? The gnome in the blue hat is the leader, so she's drinking some tea, but everyone's like making notes on the index card for like how many times they're seeing each tag, and they've got these wonderful toadstools that they're working under. Lots of fun. Lots of fun. So yeah, as we see this, the gnomes are going to make tally marks, and we can see this happening here while the gnome is making the tally mark under best dog for the number of times that they're seeing, the tag best dog. And tally marks are just like the little slash mark, and this way each individual card keeps track of one tag. And this is going to be important later, similar to how when we were writing down all of the Instagram usernames, we wanted to write it down on a bunch of different index cards instead of paper, instead of one piece of paper. It's so that we can split it up later. So super useful. Oh, hello, Professor. He's taking a little nap underneath the desk now. Okay, and now we see one of the gnomes with the red hat maybe went out to a party with their friends, and they're maybe a little sleepy, and they're gonna take a nap, right? And this party, they maybe had a little bit too much chocolate milk to drink, so they're just not feeling great. So they're gonna take a little nap underneath the toadstool. And this happens with computers too. So just like when playing a game or doing a group project, sometimes someone has to leave. And in this case, this is part of the job of the gnome with the blue hat, is to handle this situation when one of the gnomes gets a little tired. I believe the British expression is tired and emotional. And so in this case, if one of the gnomes is unable to finish their work, the gnome with the blue hat finds another gnome to step in and take over that gnome's work for them. And this is really important because the larger a group project you have, the more likely it is that someone is going to have something come up, right? Like maybe I'll find out that the professor is sick and I have to leave the group project right away, The more people there are, the higher chance there is that someone, went out to a party last night and is going to fall asleep. Okay, so yeah, mental health day exception is super important. Realistically, this is as far as I got with the illustrations. We have a lot of other things going on though too, right? Here, I'll go take a, wait, no, mouse, come back. No, there we go. So unfortunately, the examples are in Python in the code section. I'm also going to make a Scala version of them. We'll talk about why. They're in Python in a little bit, but we can see, you know, here's the text, and there's a part one which is designed to be all nice and with illustrations, and then there's a part two which is where it's just like, okay, cool, we've made bad life choices and now we're going to use computers instead of really cute gnomes. And I would love anyone's feedback or input on this. Anyways, yeah, and so it's linked here, and you can always email me as well. So the examples being in Python, not ideal, of course, Scala conference. It does still teach people functional programming. And the reason why the current or the first draft is in Python is just there's not a lot of other resources for kids in Scala. And I wanted to try and teach people functional programming, but I didn't want to teach them programming language from the ground up. I wanted to be able to reference like, hey, what's up? If you don't know anything about programming, that's totally cool. Go take a look at this other book. And there's a whole bunch of options in the Python space and not so many in the Scala space. And, you know, we'll keep working on this and try and make a happy Scala version as well. Go here. If you want to go play around with the code and the examples and stuff, all kinds of fun. Okay, now it is time for our first abrupt topic change. So we go from Professor Timbit taking a nap to cheesy jalapeno Cheeto mac and cheese, which I'm going to be honest with you is I actually like this one. This one is really good. I don't like the red colored box. Oh, yeah, here. Let me share the slides. There we go. Okay, so yeah, so we're going to talk about custom encoders in Spark. So what are custom encoders? Custom encoders are just a fancy way of saying custom serializer, except unfortunately, we don't have the same flexibility as the serializers in Spark RDD world. So we have this slightly different concept that's fundamentally the same thing, just more annoying to deal with. So why do we need custom encoders? So there's a whole bunch of different reasons. And I think in the talk before, they were talking about custom data types at one point. And so that's one of the situations where you might need a custom encoder inside of Spark data frames and data sets. But the other one, which is the one that I'm going to focus on a little bit here, is data that is not encoded efficiently by default. And as I was talking about, or alluding to, I suppose, one of these situations would be things like sparse data, really anything where the standard serializer just is not going to be great. So sparse data, ranges, repeated values, all of these things, Spark's encoders don't have any special understanding. They're just going to sort of represent them in the naive default fashion. And this can be a challenge because Spark loads data from data sources which do have efficient representations for things like sparse data, ranges, and repeated values. And even Spark's like parallelize has efficient representation for ranges. But when we come to data sets, we don't have those anymore. And this is really not good because you can get into a situation where you load something that's like literally kilobytes and it explodes into gigabytes, or you load something that's gigabytes and it explodes into an out of memory exception. And so that's really one of the main reasons why I think we need custom encoders in Spark. So yeah, like I was saying, it's like writing a serializer, but more annoying. Kind of sucks. Yeah. So this is what a custom encoder looks like. And unfortunately, custom encoders, well, they are part of the API. I would say that they don't really meet the same stability guidelines as the rest of the Spark API, which is already not great. But you know, it's okay. Oh, let me check my audio. Oh, huh. Okay. Cool. Okay. Yeah. So, anyways, this is the magic. All kinds of fun. And so I'm lazy, right? If we go back and we look at if we go back and we look at the sort of why sparse data, ranges, and repeated values, you know, there are really great ways to represent sparse data. There's a really great way to represent ranges, and there's really great ways to represent just like general repeated values. But they're all a little different, and I'm lazy. And you know what does a pretty okay job at all of them, but not amazing, is compression. And so I was dealing with some sparse data, and I was just like, you know what? I'm just going to implement compressed encoder, because that's going to be good enough for both the sparse data and the repeated values situation. And now we come to some terrible things, which is incidentally really, really frustrating for me, which is how Spark does its code gen. And so we obviously want to do code generation for serialization, because if we don't, then we can't shove everything together and have the whole stage code gen. And that would just be, you know, not very efficient. Whole stage code gen, all kinds of fun. Unfortunately, code generation is represented as a string and then compiled with Genino. And so this string is really easy to make a mistake in, and then you find out at runtime. So it's really important that when you write custom encoders, you test the shit out of them. And this is terrible. And I know this is terrible. And I have tried so very hard to make it so that this is not what we're doing. But yeah, I lost that argument. Specifically, the most recent time that I had this argument was back when we were implementing code generation for, I want to say, decision tree evaluation. And I was trying to convince people that we should really use macros, but I lost that argument. And to be fair, right, like the reasoning behind this is not completely like crazy pants, or I shouldn't say crazy pants. It's not completely off the wall. It's yeah. So the reason for doing it this way is that the Scala macros are a little bit slow compared to the Genino compilation, and they really didn't want to have the logic to decide when it makes sense to do code generation or not based on the input data size. They just wanted to always be able to pick code generation if it was available. And for that to make sense, you have to have really, really inexpensive code generation. And so this is the path that we went down. Like I said, lost that argument. It sucks. Oh well. Yeah, and this isn't the full thing. Like, it keeps going for a while longer because it's writing Java code inside of the Scala program. So that goes poorly. And as I was saying, the other thing is, like, as we can see here, there's this part new in 3.2, and that is, you know, if we were keeping with the guarantees that we have in Spark for how our APIs evolve, in theory, we shouldn't have added with new children, or if we did, we should have added it with a default implementation. But we didn't, and that's the reality, is that not many people actually implement custom encoders. And so if you do decide to implement custom encoders, you should be prepared for your code to break every time you upgrade Spark, which is unfortunate, but like, let's be honest, that's the reality of Spark. Okay, yeah, like I was saying, this code generation, really, I'm really sorry. I'm optimistic that maybe in Spark 4 we can revisit this code generation and do something that isn't a dumpster fire. But that optimism might be misplaced. Yeah. Okay, yeah. Yeah, we got a little bit of time. The decoder is roughly the same thing as the encoder. We also have this giant pile of Java code that we generate that is just all kinds of terrible, really depressing. Happiness is an illusion. It's okay. So you might be wondering to yourself, okay, that's how we write encoders. How is Spark deciding which encoder to use? And the answer is implicits. Everyone loves implicits, except now they're terrible. And unfortunately, while this works pretty well for the situation where you're adding new data types, we didn't do a really good job of thinking through the situation where you might want to replace one of the built-in encoders, because it's kind of annoying to do. And if we go back to the example that we were going through, we can see here that I'm trying to build a replacement encoder for arrays of bytes, and yeah, that's already built in, and replacing it is painful. If you're interested in seeing, you can see it in the test suite where I do the magic to make it work, but it does suck. Okay, so what else sucks about encoders? Encoders are still row-based, and it turns out that that's not great, because columnar representations are really awesome. I would love to see us adopt batch-based encoders to support formats like Arrow, but admittedly, right now there are no concrete plans for this, but I think it's really cool. And I think with the recent launch of Flight SQL, I think with, is there a reason not to extend static invoke for a custom encoder? That's a great question. I don't know. Yeah, sorry, wait. Yeah, no concrete plans to extend beyond row-based just yet. Okay, okay, so we do have enough time that I want to go back and I want to show you something else. Yay, okay. This is the other thing in Spark that I've been working on that I'm excited about, and I want to try and convince more of you to be involved with. So, I don't know how many of you have been working with Spark and had a slow running job or an exception that you didn't know how to handle. I'm going to go ahead, I'm going to say like, yeah, I have an exception, because that's the reality of a lot of the times in my life, is I have an exception in Spark. And so we can see here like, hey, these are some of the different kinds of exceptions that you might get in Spark. So let's say maybe it got a too big broadcast join. And so then we have some like advice about like, hey, this is how broadcast join works. And maybe you're like, you know what, I set this value and it's still not working. Then you might go back here and you might be like, okay, I disabled broadcast join, but I'm still seeing broadcast, like what's going on? So then you might go here and you get like, tables are getting broadcast even when broadcast is disabled. And then the answer is like, hey, what's up? If you have a subquery like this, then you're actually going to get a broadcast join, even if you've like told Spark not to do any broadcast joins, which is super confusing, but like, hey, whatever, computers suck. Right. Failed to read non-parquet files. This one is more like a iceberg thing, but people tend to run into it with Spark. And anyway, so there's just like, there's a whole bunch of different exceptions. Obviously, this is not all of the different kinds of exceptions that you'll find in Spark, but you know, it's hopefully enough to help people along their way some of the time. And let's go take a look at slow running jobs as well. Okay, and so one of the things that like I was writing about is too big DAG when iterative algorithms go wrong, or go bump in the night. And you know, this is not perfect, but we see here that the solution is often something like checkpointing. And I should really add some more links to this, but we'll get there. Relatedly, if you're looking at this and you're like, you know what, that looks awesome. I have some free time and I would love to contribute to this. Then have I got wonderful news for you. It's here. And you too, I'm actually going to paste this in the chat because I would love to put more people into contributing to this. You too can submit PRs. Yay! It's in Markdown. And if you're having any difficulty with the flowchart, feel free to reach out to me. I know that the flowchart format is not great. It's Mermaid, which you know is becoming more popular thanks to GitHub, but is still something that a lot of people aren't familiar with. So I'm of course more than willing to help. And there are 8 wonderful contributors. You can become contributor number 9, and I would love to see more people contributing to this because, yeah. Relatedly, like as this implies, export external.sh. This does come out of my work at Netflix, and there is an internal version, which if you join Netflix, you can see the internal version as well, which honestly is pretty much the same thing, just with some more links to some internal use cases. But my boss would be annoyed if I didn't try and recruit at least some of you. Okay, so I think that's really it for me.